Okay, everyone, again, welcome to the Linux and the Programming Languages course, the LTS. And today we will be continuing our discussion on the Linux networking. Today is lecture 7 on the Linux networking. We started learning about the distributed file system. We learned about the Sun NFS file system. Now we will be learning today the AFS or the Andrew file system. This is the second half, and then we will do some comparison between the NFS and the AFS, and then finally we will look at the NIS, which is the Network Information System, and that will pretty much conclude the networking portion of this course. So before I start talking about the AFS or the Andrew file system, let me summarize what we discussed last time. We actually started talking about the distributed file system or remote file system. Some of the benefits of the remote file system are, one is reliability. So again, this goes back to not many people carry multiple copies of the data, and if you are carrying multiple copies of the data, it's not like a much protection. So you need to have like that kind of a reliable mechanism. And then the second thing is like the backups are very nice, and especially like if the backups are done in a temperature controlled, humidity controlled room with fire suppressed facilities. And the time travel is nice too, meaning that you can go back in time and actually capture some of the data, things like that. It's also like pretty nice. The second aspect of the remote file system is the sharing. It allows the multiple users to access data, but you need to provide authentication system. The security becomes an issue there, but in general it allows this sharing. So again, that's another benefit of the remote file system. We actually talked about several key terminologies like transparency, things like that. So again, it all goes back to these benefits what the remote file system gives. The other benefit is the scalability. Again, buying large disks are cheaper, so centralized large disks for multiple users is a good thing. Locality of reference again. So this is one thing is we don't use all the files all the time in a single day. So why do we need to carry everything in expensive portable storage? Might as well have it in remote files and access only the files that we need. So again, that's another big benefit of the remote file system. And then finally the auditability, which is essentially we can make sure we know who did or who submitted the data, what they submitted, when. With the central storage, it's much more easier that we can get to that. So there are all these benefits. This is what we talked about in the distributed file system. Then we looked at the NFS file system itself. The architecture is fairly simple. It uses a stateless model for the server. All the information about a particular files are stored in the client side. The client has this NFS client. The application program accesses just like it's a local file through a virtual file system. The virtual file system understands whether it's part of the local files, the Unix file system, or it is a remote file. In that case, it actually mounts those files as a remote file, and then it communicates through the network to the NFS server on the server computer, and then gets that data back into the application program. So from the application program, it still looks like a local file itself, and it uses this mounting as a way to get the files. So the NFS client keeps track of what goes on, where is the file, all those things. Whereas the server side, it's basically a stateless machine. So the advantage is that you can add as many clients as possible, still you don't lose any performance edge. Basically, the performance itself does not degrade by accessing. So this is all we saw, basically, like how the Unix system call works, and then how the operation happens. Now let's look at the summary on NFS, so the network file system. Again, it's a workgroup network file service kind of a protocol, and any Unix machine can become a server. And it's fairly easy to set up a server for the NFS on any Unix machine. The machines can be both a client as well as a server. So some files on my disk and some files on the other side, and then everybody in the group can access all these files easily. But as we saw, there are some serious trust issues, some scaling problems that we saw. The stateless file server model goes only up to some point. Basically, it's only a partial success. So now let's look at another file system which is completely different from the NFS, or essentially, like, I mean, it uses certain other concepts to build this remote file system. Let's look at that. That's the Andrew file system. So again, one similarity between the AFS and the NFS is that both provide transparent access to the remote shared files for Unix programs running on workstations. And similar to the client server model, what we saw in the NFS, the AFS is also implemented as two software components that exist at the Unix processes. They are called WISE and Venus. So let's look at the picture on this one. So here you have all these different workstations with its own Unix kernel. There are some user programs. It also has what is called this Venus, which is actually a process. Now in the NFS, we had the NFS server as a separate file system, basically. So, or it was actually like down here. Whereas the Venus is actually a process that is running on the Unix kernel, just like a user program. So, and then all these programs are running, and then the server side, you can see that WISE is also a process or a program that is running on top of the Unix kernel, and there are a number of files. So these programs themselves communicate and make sure that what is there in the file system is given to the user. So just a simple contrast between these pictures. If you look at this picture versus this picture, here the NFS client was under the file system as a particular file. So somehow or somewhat static, you can say. And then even the NFS server was also another file which is under the virtual file system, again a static, and how they are linked together. So that's why, like, we use all these the NFS protocol itself to link these files. Whereas in a Andrew file system, actually the Venus and the WISE are programs that are being executed, so they are processes. So, and then the program, actually the user program, communicates through this process to get to the various file systems and get the data back to the program that is running. So in the Andrew file system case, the files are available to the user processes running on the workstations, are either local or shared. So and the local files are handled as the normal Unix files. They're stored in the workstation's disk itself and are available only to the local user processes. The shared files are stored on servers, and copies of them are cached in local disks. So again, it allows that the caching mechanism. The namespace seen by the user process that we will show in the next picture. So again, in this one, you can see that actually when you have the shared one, they are actually shown as symbolic links. between the those files, and that's how it knows that okay, that's the remote file. So the Unix kernel in each of the workstation and server is a modified version of the BSD Unix, which is the Berkeley systems Unix. And essentially the modifications are designed to intercept the file commands, which is essentially the open and the close, and some other file system commands as well. And when they refer to this shared memory, and then pass them to the Venus process in the client computer. So essentially, like the Venus intercepts these, submits to the WISE, and then that WISE processes it to the Venus of the client computer, get the information, and then submits back to the, the process that is looking for this information. So here a quick setup, basically, like in the picture of the system call interception itself. So here the user program calls, it generates a Unix file system call, goes into the Unix kernel. It knows that actually it is not the local disk access, but it's actually a remote file access. So those non-local file operations are sent to Venus, which actually captures that and then communicates to WISE, and then goes to the server and then gets that information and brings it back to the user program. So let's look at this process in a little bit detail. So here the user process is open, and we know this command, the open with file name and the mode. Once the user process initiates this command, the Unix actually has this code, which is if the file name refers to the file in the shared file space, pass the request to Venus. Otherwise, just open the local file and return the file to the user process. And so the result of this operation will be a file descriptor. So now let's look at what happens when this file system, or the file that is file name that is requesting, is not in the local file, but it's actually a shared file. So now the request is sent to Venus. The Venus actually checklist of files in the local cache. If it is not present, or there is no valid callback promise, send the request of the file to the WISE server, that is the custodian of the volume containing this file. So, and if it finds that file through either a callback from the WISE, or otherwise basically the if it is in the local cache or there is a callback promise, then place the copy of the file in the local file system, enter its name in the local cache list, and return the local name back to the Unix. So it goes back to the Unix kernel and then goes back. Now when the Venus makes a call to WISE, essentially WISE reads this call and says, okay, I have this file in my file system, so I will transfer that file and the callback promise to the workstation which is requesting this, log that callback promise, and then basically exit at that point. So once that file gets transferred back, then this is basically like the copy is in the local cache, so that now it can be served. So now let's look at a read pointer essentially. So for reading a file descriptor, the buffer, and the length, this is not an issue basically. Now it does not go to Venus or the WISE, because the Venus already placed, or the Venus already placed that file in the Unix system as a local file in the cache. So now the read operation is just reading that. Then it's a normal operation like this normal read operation on a localized file system. Now if it is a write operation, now again it does not go into the Venus or the vice, but it just does the operation in the local file system itself, the local copy. Now the interesting thing is when you close that particular file. When you close the file, it closes the local copy and it also notifies the Venus that the file has been closed. So that's when now the Venus will kick in and then essentially it looks for if the local copy is changed. If it is changed, then that it will send that copy to the Y server. And Y server now puts it in its file system. It replaces the file contents and send the callback to all the clients that are holding that that file, that callback promise, saying that okay, this file is modified, now you need to modify your local cache file. So you can think of this system basically the Venus, the network and the vice as processes running, monitoring what is going on in the file and communicating back and forth when the files change, or if some other Venus process is requesting a file, it passes that file. So think of there are two systems here. One is the user process and the user kernel. The other one is the Venus and the vice systems. So and then they both have a shared local cache essentially. Even though here the shared memory is actually situated in vice, you can think of them as updating a local cache that essentially like that's your area where both of these processes can gain access to. So that may be a better way to understand how the whole thing works. In the contrasting with the NFS, you would have seen that actually the processes are pretty much the same. The file systems themselves have a separate basically, and so there is a localized file system and then there's a remote file system, and basically like the common link is through the mounting and unmounting of files. So now let's look at some more important components of the voice service interface. So this is basically like the server side essentially like what is shown here. So there is a fetch command which returns an attribute and a data for a given file ID. So this essentially like returns the attribute and also records any callback promises on that particular file from that the centralized file server back to the client, back to the Venus program. The second command is the store file ID attribute data. This updates the attributes essentially and the contents of a specific file. This is what the Venus will give the command once there is a closed file. It basically like then sends the store command to the vice to make sure that the contents are updated. Then there is another command called create that returns a file ID. This creates a new file and records a callback promise on it, and then sends this file ID to the requesting process. The remove file ID removes a specified file, and then we have set lock file ID with the mode. This sets the lock on the specified file, and the mode of the lock may be shared or exclusive. The locks that are not removed will expire after 30 minutes. And release lock again with the file ID unlocks the specified file or the directory. And remove callback for a file ID also informs the server that the Venus process has flushed a file from the cache. And break callback file ID, this is made by the Y server to the Venus process. It cancels a callback promise on a relevant file. So in summary, the AFS is a worldwide file system. So if you look at the structure here, the servers hold this file system here, and you can pretty much any other files that are there, it's mirrored under that this particular file system. So you can almost think of this as a worldwide file system. So NFS may be like one per network. Here the AFS is just only one that is needed. And also, like, since all these callbacks and all of them are tagged, and basically like all the file management is done internally, it has a very good security as well as good scaling. And as you see, basically the names themselves, they don't have to collide. Basically it's a global namespace essentially, because the files themselves are copied back and forth into various clients as a management. So again, you can think of this as basically like the server still keeps track of the state of the overall network at all times. So this is not a stateless server as we have seen in the NFS file system. And it's a professional server infrastructure per cell. So essentially, like, I mean, you have to be trained on this. So you cannot just set it up just like the NFS, where any Unix server can be set up as a, or any Unix client can be set up as a server. There's only like about 190 AFS cells between 2005 and 2011. The 8 are in CMU and 15 are in Pittsburgh. Again, in this one, again, it's a no write conflict essentially. Like, I mean, kind of that is the protocol that is implied, because when one particular client checks out a file, the others may not get the right access. This is only like a partial success, because now you have like there is a time lag between when the server updates the file and then it communicates to all the clients to also like change the file. So there are still some issues with respect to how we can create the file and model the file. So the key differences between the AFS and NFS, essentially with NFS, the different clients can mount the same file system in different places, whereas AFS is just one system for the entire planet. So again, this goes back to the basic differences. Basically, like every client sees the file system as its own unique file system in a NFS environment, truly by replicating the file mount points. Whereas in an AFS system, the centralized server stores all the files, and basically the processes themselves communicate to the centralized server in order to gather those files. So that is one of the key differences between the NFS and AFS. And unlike NFS, the NFS actually uses this etc file systems as a mount point, and this is where there is a map between the local directory name and the remote file system. The AFS does all the mapping at the server. So this is a tremendous advantage. This holds tremendous advantage of making the served file space location completely independent. So everything is controlled by the server. So the clients have seldom anything to do with that, anything to do with changing the namespace. So there is no like namespace collision, and also the file space location is also completely independent, because the server is the one that controls where the particular goes in, where the particular file goes into. So you can actually move it around and still you won't see any issues basically because the server still has the mapping of where the files are. Whereas in an NFS, which is the next one basically, so um, the when you change a file, essentially the in an NFS, essentially you need to change the etc file systems file on the 20 clients. Even if you are taking like just taking the /home offline, or while you moved it between the servers. With the AFS, you have to just simply move the AFS volume, which constitutes the /home between the servers. You do this online while the others are actively using files, and without no disruption to their work, because the changing whatever you're doing, you're going to send a callback notice to those clients via the Wise and the Venus to just change the notification basically. So in fact, when you're changing a file, you don't even have to notify the Wise server, because when they access to either close the file or open a new file in that particular directory, the mapping is already in place in the server to go to that particular directory. And then regarding the security, AFS is far more secure than NFS. It uses this special authentication called Kerberos. We talked about this Kerberos briefly in the last lecture. I just wanted to give you some more details on the Kerberos. Some of you may have already known about Kerberos. Kerberos actually provides a centralized authentication server to authenticate users to servers and servers to users, and this relies on the conventional encryption, and it does not make use of the public key encryption. So there are some additional things basically, like there are some other encryption services that it uses. So the basic idea behind Kerberos is essentially there's a server where you send the your so the as a client or a user, the user data is sent to that server, which keeps track of which users are authorized to use that particular request. So and then it sends back the authentication information. So once you receive the authentication information with that certificate, you can go into a server for a given service, and while you're doing that, even the server is also authenticated by the same server by the same Kerberos process, which says that okay, that server is authenticated to actually now receive your service request and deliver the service. So the server gets the same thing. So this is what you see, like I mean, in most of the websites when they say basically like okay, the certificate is now expired, do you want to redo the certificate? Essentially, like I mean, the certificate is the authentication provided by the Kerberos server. So with that, we conclude the distributed file systems. Now let's look at the network information system, which is essentially an application of all the things that we talked about, which is both the DFS, DNS, everything put together. So a network information system provides a generic database access facilities such as password and groups files to all the hosts in a given network, so that the network will appear as a single system with the same account on all the hosts. So you log in from any of the hosts. So today, like when you have a machine and you're logging in as yourself in that machine, tomorrow you go into your friend's office and you try to log in as your with your authentication information. What if the computer doesn't let you access and it appears different? Since all the computers are connected in the same network, don't you think that that also needs to take in your information and give you the access? I think that's what the NIS provides. So it basically distributes the hostname information from /etc host to all the machines on the network. So from for a given user, the client, everything, including the network and all the network access points, everything appears as a single network. So it doesn't matter whether it's a subnet of a subnet of a subnet, and all the subnets are grouped together. The NIS provides a single access or uniform access across this network. The the network information structure is based on remote procedure calls. This we saw already. It comprises a server, a client-side library, and several administrative tools. Originally, the NIS was started by Sun as Yellow Pages system. So it used to be called Yellow Pages, but then British Telecom had exclusive rights on this term Yellow Pages. So Sun had to discontinue the usage of the Yellow Pages. So then they named it as NIS. So that's the origin of the network information system. But the YP is still there in a lot of the commands, such as YP serve, YP bind, etc. These are the basic commands for building a network information system. So the NIS support replication with the slave servers. We saw that basically, that's what it does. And essentially, like the changes in master server need to be pushed using YP push command to the slaves, if any. And it uses the Berkeley database for fast lookup. We saw the very first thing is essentially it's a database based um, system for authenticating password and the group files. And each file might be translated into multiple network information system maps. So this is using the etc password. So you can have like password by name, password by user ID, things like that. So various forms of authentication information can be provided. So now let's look at how to set up an NIS server. So essentially, like we use these commands: yum install ypserve. Then we provide a YP domain name, like YP domain name Linux is better. Then we start the YP serve process, which is in the /etc/init.d. And if you want to set up a master process, then we say basically YP init-m. And for the slaves, we say basically it's YP init-s and provide the master's IP address. Then we essentially like read from the yp.config. Essentially, like that's where we set it up as this domain. So this is what is the outcome essentially, which is the yp.conf, where we set up this domain. Linux is better, and basically, like now you have um, the configuration defined. Now you can actually start the process, which is using the YP bind command, and we just say basically YP bind start, and then it starts the overall process. So the YP serve start essentially starts the NIS server domain, and even when you give the master command, that will prompt you to add the slave command, and Control D is to end. And then finally the NIS client daemon itself is started by the YP bind command, and this needs to be run both in the server side as well as the client side. And then to verify, we use the the PS minus AUXW, which is essentially like we want to make sure that the YP processes are running, and then YP which is another command, YP cat, YP servers essentially, and then YP cat password and YP cat group. So these are all essentially commands to get the information regarding the NIS system. I would like you to actually use some of these commands in your workstation and see what is the result. And also you can also type in man for each of these commands, essentially the YP which, YP cat, etc., to find out more information on how these commands work. And to run the NIS server automatically, the /etc/sysconfig/network needs to be updated with the NIS domain. So basically, just before the NIS domain equal to the domain name, and then you give these commands: check config YP serve on, check config YP bind. So again, you need to set up the YP serve, do the binding, and then essentially like if want to do like other services to be offered. So for example, the YP password is one of them, which is you can do the check config YP password, make that also on, so that you can give the users to do these commands. And YP chsh is also like another one, that is the change shell command. If you want to provide the users with that facility, then you can basically turn on that feature also. So now the other thing is, how do we sync data between the master and the slave NIS servers? So from the server, we can just provide the YP transfer command with the map name. From the server side, from the slave side, we just provide the YP transfer command, and from the server side, we do the YP push command. We already saw this YP push, essentially to push that information back to all the slaves. So any new map changes are pushed through these two commands, either from the slaves to the server or servers to the slave. And some sites use their backend databases and make NIS servers fetch the data from this central source. So they have some backend databases already defined, and then it basically like NIS servers fetch the data from this source. Essentially, like they use some cron job to do this one. For example, this is a transfer 12 per day, which is basically every other hour. It basically transfers that. Or they can use a cron job, which is YP transfer 1 per day, 1 per hour, which is every hour it transfers that. So here essentially, like this is just a sequence of command that you can try it in your machines, which is set up the YP domain name called in linux.ease.better, and then essentially you configure then look for the config file, which is yp.config, and then you basically do the YP bind start. Then the NIS to each of these lines, the password and the group essentially, and then use the various commands to debug, which is the YP which, YP cat password, and then try to log into a user account. And then this is something that we saw, basically like how to run it automatically. And then to change the password on the NIS server, it's the YP password command, similar to password. So this essentially changes the password across all the clients, so that that is through that YP transfer process. It pushes into this service. And then to change the login shell in the on the NIS server is a change shell command with YP in front. So this actually concludes the topic for today. I think we will begin the programming classes the next one. So today in the server in the Linux networking class, we saw two items. One is the Andrew file system. We now know what is an Andrew file system and how to contrast between the Andrew file system and the NFS that we learned in the last class. And then also we learned about the NIS, how to set up NIS, and also like what are the key points about NIS and why do we need NIS. Again, thank you very much for attending, and thank you. See you in the next class. Thanks.
Hello, sir.
Yeah, hey Sandeep.
Okay, so done with the class, right, sir?
Yeah, so today it was only like about 40 minutes, right?
Around 41 minutes, right?
Okay.
Okay, so let me send you the slides by the day in today here, like within 4 to 5 hours.
Okay.
Okay, so starting the Pearl basic, right, sir?
Yeah.
Okay, I'll send it, sir. By the way, like while sending that particular thing, I'll be sending my contact number to you also.
Okay.
Okay, so like if anything urgent, like you can just call me and just put me a message.
Sure, sure. And you know what? Even next class, let's start at 10:30.
When we can plan, sir?
Same thing, right? Now we'll go with like the Wednesday and Sunday.